Hello again. This is section 6.6, the law of cosines. So in this section, if you recall back in 6.5 with law of sines, we were finding missing sides, missing angles. We're going to be doing a lot of the same in this section, but now we're going to have triangles where we don't have the necessary information to use the law of sines. So we're going to need to use a new law, which we call the law of cosines. Okay, so here's our law of cosines. Notice here that all three of these formulas are very similar to each other. It's just a matter of what information is given. So in the first equation, we have a squared equals b squared plus c squared minus 2bc times the cosine of angle A. In this case, on the right-hand side, whatever the two values are that you're squaring should also match the two values that are being multiplied before the cosine. So we have b and c in both of those cases. And then the angle that goes inside the cosine should always be the angle across from the side that you started with. So in this case, we started with side A and we squared that. So we're going to put angle A inside of our cosine. And the same pattern follows with the other two. We start with b squared. That means we're doing the cosine of b. And then we have a squared plus c squared, which means we need a 2ac. Now, the cases where we're going to have to use law of cosines is if we're given all three sides of a triangle and none of our angles, or if we're given two sides and the angle that's between those two sides, because in both of those cases, we wouldn't know an angle and its opposite side to be able to set up a law of sines. And so we're going to have to use law of cosines for those two cases. Okay, so here's our first example. Tunnels to be built through a mountain. To estimate the length of that tunnel, the surveyor makes the measurements shown in the figure. We want to use the surveyor's data to approximate the length of that tunnel. So notice here, we've got the surveyor standing out at point C. He's measured distances to point A on the left side of the mountain, point B on the right side of the mountain, and the angle that's between those two sides. We're looking for that side length, the distance through the mountain that's across from angle C. So we're trying to find the side up at the top between A and B. Now, in this case, we can't set up a law of sines because we only know one angle and we don't know the side length across from it. So that prevents us from using law of sines. So as soon as I see that, that tells me we have to go with law of cosines. Since we're looking for side C and we know angle C, that tells me I'm going to use c squared equals a squared plus b squared minus 2ab times the cosine of angle C. Now at this point, we can just start substituting the information that we know. We're looking for C, so that's going to stay c squared. A is going to be the side across from angle A, so that's 212 squared, plus side B should be across from angle B, so that's 388 squared, minus 2 times A, which is 212 again, times B, which is 388, and then the cosine of angle C, which is 82.4 degrees. Now, in this case, because everything on the right-hand side is a number, we can actually just put all of that information into our calculator. Be sure you're in degree mode when you do this. And so that should give us now 173,730.24. Now, since we're looking for C and not C squared, we still need to take a square root here. So I'm going to take the square root of both sides. So C should be equal to 416.8. Now, in these word problems, always look for units. In this case, our linear unit was feet. And so since we're looking for the side length across there, that should also be measured in feet. And as always, just pay attention to what the problem is asking for in terms of rounding, especially in WebAssign. Make sure you round to the correct number of decimal places. Here, they didn't tell us what to round to, so I'm just rounding to 1 decimal place. All right, so example 2 says the sides of a triangle are 5, 8, and 12. We want to find all the angles of that triangle. Now, I'm going to start by just sketching the triangle. And so it really doesn't matter. I'm not drawing this to scale. So we have A, B, and C. Side A should be 5. Side B should be 8. And side C should be 12. Now, in this case, because we don't know any of our angles at all, we know we can't set up a law of sines problem because we would need the angle and its opposite side. Since we're only given 3 sides, that tells us we're going to have to use law of cosines. Now, for this one, since we're given all 3 sides and we need to find all 3 angles, it really doesn't matter which angle we find first. I'm just going to go with angle A. So I'm going to use A squared equals B squared plus C squared minus 2BC times the cosine of angle A. And just like last time, I'm going to start substituting information that I know. Now this time we know all 3 of our side lengths. So we know that side A is 5, so that gives us 5 squared. We know side B, that's going to be 8 squared. Side C is 12, so we square that, minus 2 times B times C. And then the cosine of angle A, because we don't know angle A yet. Now at this point, since the right-hand side is not all numbers, we actually have a variable over there, we're going to need to go through and simplify this step by step first so that we can actually solve for that angle. 5 squared gives us 25. 8 squared is 64. 12 squared is 144. 2 times 8 times 12 give us 192, and then cosine of angle A. Now at this point, I'm going to go ahead and start adding some of these things together. So we have 64 and 144. We can combine those. Be careful, we can't subtract the 192 because it's attached to that cosine of A. So I'm only going to add the 64 and the 144. So we have 25 equals, this should give us 208. And minus 192 cosine of A. Now at this point, since again, I'm trying to isolate that cosine, I'm going to move the 208 to the other side by subtracting. So 25 minus 208 should give us a negative 183. And now to get the cosine by itself, I'm going to divide by negative 192. So we get negative 183 over negative 192 equals cosine of A. And then recall, if you're looking for the angle and you're trying to get rid of a cosine, now we can use our inverse trig function. So I'm going to take the inverse cosine of 183 over 192. And that should give me my angle. And notice here, I just canceled out the negatives. That's why I was able to make both of those positive here. Right, so make sure you're in degree mode in your calculator. We're going to do our inverse cosine, 183 divided by 192. And when we do that, we should get 17.6 degrees. All right, now once we know that angle, we still need to find the other 2. Now, you might be tempted to say, well, since I know angle A and I know side A, let's just use law of sines. You technically can, but remember with law of sines, there are those occasions where you end up with the ambiguous case, and then you're choosing between 2 angles. If in this case we just use law of cosines again, then we're guaranteed to get the correct angle, and we don't have to worry about that ambiguous case. So I'm just going to use law of cosines again to find one of the other angles. I'm going to go with angle B. So we'll say that B squared is equal to A squared plus C squared minus 2AC times the cosine of angle B. All right, again, we're substituting all the information we know. So this is going to be 8 squared equals 5 squared plus 12 squared minus 2 times 5 times 12 cosine of b. And again, I'm going to simplify what we've got here. So that gives us 64 equals 25 plus 144. 2 times 5 times 12 should be 120 cosine of b. Combine the 25 and the 144 here. So 64 equals 169 minus 120 cosine of angle b. Now we subtract 64 minus 169, gives us negative 105 equals negative 120 cosine of b. At this point we can divide. So negative 105 over negative 120 equals cosine of b. And now we can use our inverse. So inverse cosine of 105 over 120. And if you wanted to simplify that, you could. But just know that we're going to use our calculator to get this angle anyway, so there's really no reason to have to simplify that. So we'll do inverse cosine 105 over 120. And that should give us, if we just round to one decimal place, 29.0 degrees. Okay, so now we know angle B, 29.0. And the only thing left to find at this point is angle C. Now, you could use law of cosines one more time, but remember, once you know 2 of your angles in a triangle, now we can just subtract from 180 to find that third angle. So I'm just going to do 180 minus 17.6 minus 29. And that should give us 133.4 degrees. So angle C is 133.4. That's our final angle. So again, anytime you're given 3 sides of a triangle and asked to find all the missing angles, it is going to definitely be a law of cosines problem. Start by using any of the 3 formulas that you'd like, because you need to find all 3 of the angles anyway. Once you find one of those angles, again, I would recommend using law of cosines again on the second attempt, just because that way you don't end up with an ambiguous case for law of sines. Once you know 2 of your angles, though, then we can just subtract from 180 to find that third angle. All right, example 3. So this time we're given angle A, side B, and side C. So again, I'm going to sketch my triangle. In this case, angle A is 46.5 degrees. So side B is going to be 10.5. That goes over here. And we know side C has to be 18.0. Now, since the angle given, we don't know the side across from it, that tells us we're going to have to use law of cosines again here. So since I know angle A, that tells me I'm going to use A squared equals B squared plus C squared minus 2BC times the cosine of angle A. All right, so now we'll start substituting. I don't know A, so A squared equals, in this case, B is going to be 10.5 squared. C gives us 18 squared minus 2 times 10.5 times 18 times the cosine of angle A, which is 46.5. Now, in this case, everything on the right-hand side is a number, so we're allowed to just put that in the calculator. And if we do that, we should get 174.05. And again, we need to take the square root of that now to get a by itself. And taking that square root, a should be equal to 13.2. So now we know this side over here. All right, now once I know all three of my sides, we still need to know two of the angles. Again, I'm going to use law of cosines one more time. And it really doesn't matter which of your angles you want to find. I'm going to go with angle B in this case. So we'll say b squared equals a squared plus c squared minus 2ac times the cosine of angle B. Right, now we substitute. B is 10.5. A is 13.2 now. C is 18 minus 2 times 13.2 times 18 times the cosine of angle B, which is what we're trying to find. Okay, now this is one of those cases where we're trying to get cosine of B by itself, so we are going to have to simplify each piece individually. 10.5 squared should give us 110.25. 13.2 squared, 174.24. 18 squared is 324. And we have 2 times 13.2 times 18. Should give us 475.2. And I'm going to add together the two values I can. So 174.24 plus 324. That should be 498.24. Now we're going to subtract 110.25 minus 498.24. It gives us negative 387.99. And now we divide. So we have negative 387.99 over negative 475.2. And we use our inverse cosine now. In doing that, should give us 35.3 degrees. And then once we know that angle, again, we can find the third angle by just subtracting from 180. So 180 minus 46.5 minus 35.3. That should leave us with angle C as 98.2 degrees. So again, in this case, we were given two sides and the angle between those two sides. It's another case where we have to use law of cosines. Once we know that third side, again, I would say use law of cosines again to find that missing angle, because if you try to use law of sines at that point, it could be the ambiguous case, and you could be trying to choose between two different angles. And as always, once we know two of our angles, then we subtract from 180, and that should give us our last angle. All right, now navigation. Okay, so here's an example of where in the real world we might actually use a lot of this trigonometry. Now, most of our angles that we're familiar with, we're measuring from the horizontal, right? We're measuring from that x-axis, usually in a counterclockwise direction if they're positive angles, and obviously clockwise if they're negative. In this case, though, with bearings, we're always going to measure either from north or south. So we're actually measuring from the vertical axis, which is different from what we're used to. So notice that first angle that's given, north 30 degrees east, we're measuring from north towards the east 30 degrees. And so the 30-degree angle there is actually between the vertical axis at north and the angle itself. Again, the second one, north 60 degrees west, we're starting at north, we're going 60 degrees towards the west. And then we can also measure from south, so south 70 degrees west, starting from the south pole and then going around 70 degrees towards the west, or measuring from south and going 50 degrees towards the east is that last one. Now, when we're doing our calculations, we're always going to want to work with the angle that's measured from horizontal, just like we have in the past. So our first step on a lot of these problems is going to be to figure out, well, what is the actual angle we want to work with? So notice, like north 30 degrees east, we're actually going to want to work with this angle down here, which would be a 60-degree angle instead. Okay, and so in some of these cases, we're going to actually have to calculate what our angle is based off the bearing so that we know what calculations to do now. All right, so example 4. So a pilot sets out from an airport and heads in the direction north 20 degrees east, flying at 200 miles per hour. After 1 hour, he makes a course correction and heads in the direction north 40 degrees east. Half an hour after that, he has engine trouble that forces him to make an emergency landing. We want to find the distance between the airport where he started and his final landing point. Now, I'm going to definitely sketch a picture of this one to help us see what we're actually looking at. So, all right, so the first thing we're told is that he starts from one point and he goes north 20 degrees east. Okay, so I'm going to do that. We have our point here. He's going north 20 degrees east. So I'm going to draw my compass in here. Here's north, here's east. So north 20 degrees east is going to be off in this direction like this, where this angle here is 20 degrees. Okay. Now, after he's flown for some time, he makes a course correction. So I'm going to draw a new compass in here. And from that point, he's going to go north 40 degrees east. So that's going to look something like this. Now, what we're trying to find is from his starting point at that airport to where he actually landed, what is that total distance? So we're looking for this length right down here now. Okay, and so we do have a triangle here. So we're going to need some more information about this triangle to be able to figure out that distance. Now, the way I'm going to find that, let's go back and look at what was given. So it says he was flying at 200 miles per hour, and after 1 hour, he makes the course correction. So basically, he's flying 200 miles per hour for 1 hour. Well, 200 miles per hour for 1 hour means he's going to be traveling 200 miles. Okay, and so in this case, I'm going to put my 200 miles along that first side there. Now, after he makes the course correction, says he's going to travel that course for half an hour, but still traveling at 200 miles per hour. Well, if he's going 200 miles per hour, but now only half an hour, that means he should travel half of that distance, which is only going to be 100 miles. And so this distance here should be 100 miles. Now, at this point, if I can figure out one of my angles inside the triangle, I'll have two sides and I'll have an angle, and then I can actually set this up either using law of sines or cosines, depending on the information that's given, to be able to solve for the missing side. Now, if you notice here, I'm going to try to find this angle inside of my triangle. I'll mark it right here. So this angle around here between the two sides that are given. Well, to do that, I'm actually going to think of it as three separate angles based off of that compass that I've got there. So I'm going to think about just this little piece here between east and the side length. Well, if the 40-degree angle is above that, I know that north and east should form a 90-degree angle. And so 90 minus 40 gives us a 50-degree angle just for that little piece. So I have 50 degrees there. I also know that between south and east, that part should be a right angle, so there should be 90 degrees there. And so now if I can just figure out between south and this piece over here at 200 miles, then I'll have the entire angle. Well, what we basically have now are parallel lines. So this line and this line, the north-south line, they're both vertical, so we know they're parallel. And that 200-mile length that goes between them is what we call a transversal. Not that you need to know that term, okay, but it's basically any line that goes between two parallel lines. Because of that, I know that the angles on either side of that 200 miles have to be the same size. And so we have a 20-degree angle down here at the bottom, which means that this angle up here is also going to be 20 degrees. If you ever heard the term alternate interior angles, that's what we have this time. Two parallel lines, alternate interior angles, that's why they're both 20 degrees. Now, once we know that, now we can put all three of those things together. So 20 plus 90 plus 50. And that should give us 160 degrees as the total angle inside here. Okay. So this angle in here should be 160 degrees. Now, once I have that, now I have everything I need to find my missing side. And it's up to you how you want to label everything. If you want to use X, that's fine. If you want to use an A, B, or C, that's fine. I'm going to call this side A, all right, just so I can use that first law of cosines formula. And so we're going to say A squared equals B squared plus C squared minus 2BC times the cosine of angle A. Now, A is what we're looking for, so we have A squared. B in this case, it really doesn't matter which side is which. I'm just going to go with the 100. So we'll say 100 squared. I'm going to call side C the 200. So that's 200 squared minus 2 times 100 times 200 times the cosine of angle A, which is the 160 degrees that we just found. Okay, now this time we only have numbers on the right, so we can actually put all of that into our calculator. So this should give us A squared equals 87,587.7. Now we take our square root. And that tells us that A should be 295. Actually, rounding to one decimal place is going to give us 296.0. And as always, if we have units, we want to make sure we include them here. All of our distances are measured in miles, so this distance should also be in miles. So we have a distance of 296 miles from his starting location to where he landed now. All right, so that's part A. And the second part says we want to find the bearing from the airport to his final landing point. So what we're trying to find now is not just the angle inside the triangle, but the entire bearing from north to east that he's actually traveling from his starting point to the ending point. Well, we know one piece of it is 20 degrees. So if we can find the angle inside the triangle now, we can just put those two pieces together, and that should give us the entire bearing. So I'm going to use law of cosines again. And again, I'm going to label my triangle just so we remember how we had all this set up. Remember, I was using 100 as side B, so that means angle B is down here. Angle C is going to be up here. So that means I need angle B, so I'm going to use B squared equals A squared plus C squared minus 2AC times the cosine of angle B. Now my side B is 100, so we have 100 squared equals A squared, so 296 squared. C squared is going to be 200 squared minus 2 times 296 times 200 times the cosine of angle B. Now we simplify, so 100 squared should give us 10,000. 296 squared, 87,616. 200 squared should be 40,000. Now 2 times 296 times 200 is 118,400. Again, I'm going to add what I can over here. So 87,616 plus 40,000. That should give us 127,616. And now we subtract that from 10,000, which is negative 117,616. At that point, we can divide. And we can take our inverse cosine. And so if we do that, should give us angle B is 6.6 degrees. Okay. Now remember, that's not exactly what we were trying to find. We need to know it, right? So we know that this angle inside here now is 6.6 degrees, but the bearing itself is going to be from north all the way around to that line. So now we have to add the 20 degrees to that. So we have 20 plus 6.6 gives us 26.6 degrees. And so our bearing itself from north, we're going 26.6 degrees towards the east. And so that's going to be the bearing from our starting point to where we landed. So as always, when you have problems like this, try to sketch the picture first. And in some cases, you're not going to be given every single piece of information that you need up front. You might have to actually look at what's given and kind of work through and find that angle, right? So in this case, that 160-degree angle, definitely not given up front, but there is enough information there to find it. And once we know it, then we have everything we need to use law of cosines. All right. And then Heron's formula. So this is another way that we can actually find the area of a triangle if you know all three sides of your triangle. So first thing we're going to have to do is calculate what we call semi-perimeter. Sorry, this should be a where. Okay, so where semi-perimeter is 1/2 times a plus b plus c. So just think a plus b plus c is the perimeter of the triangle. Semi means half, so we're taking half of the perimeter. That's all we're doing here. Once we have that semi-perimeter, then we can actually do the square root of s times s minus the first side length times s minus the second side length times s minus the third side length. And so all of those things get multiplied together. We take the square root, and that will then give us the area of our triangle. So if you're ever given just three sides of a triangle, this is how we can find the area now. All right, so a businessman wishes to buy a triangular lot in a busy downtown location. The lot frontages on the three adjacent streets are 125, 280, and 315 feet. We want to find the area of that lot. So first thing we're going to have to do is find that semi-perimeter. So S equals 1/2 times 125 plus 280 plus 315. And if we do that, that should give us 360 feet for our semi-perimeter. Okay. Now that we have that, now we can use our formula. So area equals square root. Start with your semi-perimeter, 360 times, and then we're just going to do the semi-perimeter minus of those side lengths. So we have 360 minus 125 times 360 minus 280 times 360 minus 315. Okay. And in this case, since everything on the right is just a number, we can actually just simplify that, put it all in the calculator together. And when we do that, that should give us 17,451.2. Oops, sorry, 0.6. And as always, if we have units, we want to include them. Since we're looking for an area this time, our linear unit was feet, but area would be in squared units. So we're going to get feet squared. So again, just another way now that we can find the area of a triangle. It all depends on the information that's given. If you know all three sides, this is a formula we can use now. All right, so that's it for this section and for this unit. As always, if you have any questions as you're working through the homework, please let me know, and I will see you next time.